This video now is a discussion on how to use the t-test for unequal variance, because in the other video there is also discussion on t-test of equal variances. But before we go that, so we have to recall the formulas for the t-test. T-test again is a parametric test used to compare between whether the two groups of the same variable are significantly different or not, or one is higher group than the other in terms of the data. So there are two types of independent t-test. Independent because the data from the other group is not affected by the data of the other first group also. So remember, this formula is for the independent equal variance. And this formula here also is the independent unequal variance. So let us try to assume that our data in our example will be an equal variance, so we can use the t-test independent unequal variance. Now, let us go to the idea of using the t-test. The same with the independent samples equal variance, the same assumptions will be carried. So we have to determine whether the data is normally distributed or the number of data is less than 30. And second is the variance is known. So we have to consider this if our data meets this assumption, so we can use the t-test. Otherwise, we will use the non-parametric test. Example, this is the example problem that will be reflected in our research problem if ever you are in the analysis of your data. Example is there significant difference in the quiz scores between section A and section B? You are going to use alpha level 0.05. So the analysis goes like whether section A and B have the same group in their quiz scores, or the section A is higher than section B. So we need to know statistically. So to get the answer, we have to identify the variables. So, sometimes if we use t-test, we have one variable but they are grouped into two categories, so or two groups. So the analysis is in terms of groups. So that's why we have the same variable. The mean of the variances, I mean the mean of the two groups and the variances of the two groups, okay? And then we have the sample size of the two group. When we say sample size, how many respondents were analyzed in group A and how many are in group B. And then we have the t-test result, in which this t-test result is based on the use of this formula, unequal variance or equal variance. So we assume that we will be using the t-test unequal variance. So the t-test result in this table should be the result of the t-test in the unequal variance. And then we have to look for the critical value. When we say critical value, it refers to the tabular value, which we can find it in the table online. And then decision is to whether accept or reject the null hypothesis. Let us remember that if it's insignificant, we have to accept the null. And if it's significant, we have to reject the null hypothesis. So the interpretation would be here equal or one is greater than the other. Now, let us go to the assumptions. How do we know that the data is normally distributed? Remember, we have the formula, the Pearson Index, as reflected in the book of Bluman 2012, Elementary Statistics, a step-by-step approach 8th edition. You can find there that it's equal to 3 times the mean minus median over the standard deviation. So the mean here refers to all the mean of all the data of the respondents in the two groups. So we will not separately analyze the two groups, but we have to put them together as one, and we get the mean, also the median, and the standard deviation. And then the PI is the result after we put the values in the formula. And then how do we know that if the data is already normally distributed and we notice that the values of n is less than 30? How do we know now that our t-test is independent equal or unequal variance? But so to do that, we have to go back also to the formula as reflected in the book of Snedecor and Cochrane 1983. This can also be found in the book of Bluman. F is equal to larger variance divided by smaller variance. So in which we have to consider the critical value equals df numerator equals n minus 1 and df denominator the the number of respondents minus 1. So if the values are not found in the table, so we can interpolate, especially if it's not easily reflected in the table. Now, our decision then, after we compute the f value, we can say that the variances are equal or not. So if it's an equal variance, then we can use the t-test for an equal variance. So the second formula, in which, in here, we have to reflect here what are the variables, the mean, the variance, the t-test, and so on and so forth. All right, so let's have an example. So in the first column example, we have the respondents 1 to 22. So as you notice, in the assumption, our n is less than 30. And then there are two sections, section A and section B. And then the scores out of 50 points example, these are the following scores. Okay, so these are the scores of the students. Now, let us now step by step analyze the test of normality. First is we have to get the mean, the median, and the standard deviation. And so we put that in the Pearson Index so we can decide for the normality. Again, the mean refers to the mean of all values in the two groups. Okay, so let's have the table command, Excel command. So we have equals average, because mean refers to average. So you highlight the data from first to the last, then enter. So our value is 30.36. For median also, you can have equals median, open parentheses, highlight all the values, and then enter. Okay, so the median here is 32. The standard deviation is equal to ST, and then you notice dev.p, dev.s. So we will go to dev.s, double click, and then S because it's sample, not the population, and then you highlight all the data under analysis there. So our standard deviation now is 10.007 and so on. So the PI now by formula, if you remember the formula, is equal to equals 3. So we will just put that in the parentheses 3. The asterisk means times, open parentheses, subtract the mean, minus the median, close parentheses and close it again. Divide it by the standard deviation. And that is our PI. Now, according to the Book of Bluman, we can say that the data is normally distributed if the values ranging from -1 to +1. So it's normally distributed. So as you notice, -4 does not go beyond -1. So it's still between -1 and 0. So it belongs to the range. So we can say it's normally distributed. So we can now use the uh, t-test formula, because the second assumption is to find the variance. Of course, we can get the variance because our data set is numerical. And then we will get the equality of variance. So we can decide whether we will use the equal or unequal variance. So an equality of variance, we will use the f-test, which is larger variance divided by smaller variance. So that means we have to get the variances first. So first is group 1. So we will get the variance equal var.s, open parentheses, then again. But in this case, the sections are rumbled, not arranged. So we have first to sort this out so that we will group all group 1 together and group 2 together. So you just highlight now all from participants down to the scores, all the scores, and then you go to column N. Column N is the respondents, column O is the section. Our target is to group them by section. So we will go to column O, check that. Smallest to largest, so okay. So what you notice now, these are all 1. So all section 1 students, all section 1. We name the students are student 1, 2, 3, 6, 9, 12, 16, and 19, and 21. And these are their corresponding scores. So these are also the students from section 2. So again, we get the variance 1, that is equals var.s. Okay, and then we get the score, not the section, but the score of the first variance. And it's 26.11. And then equal var.s for the second group. There. So it's 115.92. So what is now our f? So again, let us divide the larger, which is variance 2, divided by the smaller, which is variance 1. So our f value is 4.439607201. Now, how do we know if the variances are equal or not? We still have to find the f critical value. So to do that, in the problem example, we have to use the alpha level in the example here. We have to use the alpha level 0.05 here. So in finding the values in the table, for the F test, we have to understand that for the two-tailed, we have to get the half of the set alpha level. That's for two-tailed. And for one tail, we will use directly the alpha. And how do we know that it's two-tailed? Let's try to go back to the problem. What is being asked here is there significant difference. So we are not asking whether section A is bigger than section B or section B is lower than section A. Our question is, are they equal or not? So that's the point of interpretation. So that's why we have to find the critical value in the table. So what we will do now is we are going to find that in online. Okay, so we will just find that online. Okay, so as I look at here, we can type f table 0.025, and these are the values now, the table that we can have, and then we will visit the table that provided in this web page. So tutor stats example here. Now, as you notice, the alpha here is 0.10, 0.05, but we set our alpha is 0.05 and we divide it by 2 because it's two-tailed. So instead, we will go to 0.025. Now, as you notice, these are the numbers going to the left at the upper part. I mean to the right, these are the numerator, and all the numbers going down are the denominators. Now let's try to go back to our example, which is our numerator and denominator. For the f-test, we divide the bigger variance, which is the numerator, by the smaller variance, which is the denominator. Our bigger variance is variance 2, 115, in which this refers to the group 2 here, or the section 2. So in other words, our n here is, if you look at here below, 13. So since the df is n minus 1, so 13 minus 1 is 12. So our numerator is 12 because it's n of the bigger variance. Remember that. And then our denominator is 1 because that is our first variance, the denominator. So if you notice, there are 9. So again, by degrees of freedom, 9 minus 1 is 8. So our denominator now is 8. So again, our numerator is 12 because it's 13 minus 1. And our denominator is 8 because it's 9 minus 1. So we'll go back now to the table. So it's alpha 0.025. We go to 12. 12 is here at the last column. And then we go down to 8 there. So it's 4.1997. So let's now go back to the Excel. So it's 4.1997. Now, we have to compare the critical value with the F value. So what is now our decision? Our F value is bigger or larger than the critical. So meaning, if larger, meaning there is significant variance, degree of variance between the two groups. I mean, the variance of group 1 is bigger than the variance of group 2. They are not equal. Or I mean, the group variance of group 2 in this case is bigger than the variance of group 1. So therefore, we can say that the variances are not equal. We call that as unequal variance. So again, our variances here are unequal, meaning not equal variance. So we will go back. These are the formulas of the t-test. This formula is for equal variance, and this formula is for unequal variance. And in our test result, it's since f is greater than the critical value, therefore, we will use the unequal variance. So this one. So we will start now the statistical test. So first, if you notice, mean 1 minus mean 2 over the square root of s squared 1 is the variance of the first group over how many participants in that group. Then second variance over how many participants in that second group. And then you get the square root, and that makes it divisor of the difference of x1 and x2. So for our statistical test to be used is t-test unequal variance. Independent, t-test independent unequal variance. Okay. What will we do first? We have to get the mean first. Mean 1, then mean 2. Then we subtract mean 1 minus mean 2. So let us first assume this is the first operation. Then after that, we go down here. First, we get the variance 1 and n1. So we have to get the variance 1, and then n1. Then variance 2, then n2. And then what happened? We divide first the variance 1 by n1, and then we divide also variance 2 by n2. And we add the result, then the sum will be subjected to the square root. So what will happen now? So we have to consider that in this second operation, so our second operation after getting the variances, first you have to divide the variance 1 by, so this is equals variance 1 divided by n1. Okay. Okay, which so we will just write here var1 divided by n1. That's the okay, second operation. And then third operation is we have to get the variance 2 divided by n2. And then our fourth is we have to add the quotients. So that means equals operation 2 plus operation 3. Okay. Equals operation 2 plus operation 3. Okay. So that is our fourth operation. Then after we add that, we have to get the square root. So our fifth operation is square root of operation 4. And then after we get the square root, we divide it with the difference. So that is equals. That's the last. So we have to divide. The difference refers to the first operation. So meaning 1 divided by the square root of operation 4, which is 5. Okay. So that's operation 1 divided by operation 5. That's our sixth. Okay, so these things are important. We have to consider this because these are bases for our computation. Now, let's go now to the data based on our example. We have to get first the mean. Okay, so the mean of the first group and the mean of the second group. Okay, so first is the mean of the first group again and the mean of the second group. The mean of the first group, since we sort this out already, so we can use the data already. So we have equals average. This time we get the mean of the first group, which is all group 1. And then equals average the mean of the second group, which is here all, equals enter. There, these are already our values. There. Now, first operation is subtract mean 1 by mean 2. So equals mean 1 click minus click mean 2. Enter. And then this time we will get the variance, so that is equals var.s, open parentheses. Sorry, so that should be var.s, open parentheses. And then we highlight the data for 1 there, enter. And then we have var.s, that's also equal var.s. And then you highlight the value. Oh, no, no. N1 is we are going to count. We will not use the var. N1 is how many are in variance 1. Our variance 1, there are actually 9. So our N1 is 9. Now let's go to variance 2, that is equal var.s. And then we will also use the data for group 2 or section 2 here. Enter. And then how many again? So let us try to count. Look at here, 13. So this is 13. And then the second operation is we divide the first variance by its n. So that is equal to first variance divided by n, which is 9. Okay. And then third operation is we also divide the second variance by its n. Okay. And then fourth operation is we add the result. So meaning we have to add the result of second operation and the third operation. We have to add that. And then square root, no, after we add that, we have to get the square root, so that is equal sqrt, open parentheses, you enter 4 and then close. So that's square root of operation 4, 3. So what will happen now? We get the square root and we divide it by the difference. The difference is in the first operation. So what will happen? We have operation 1 equals operation 1 divided by the fifth operation. Our t-test value now is 2.83 rounded off. So this is our stat value. So let us consider it as our value this time. Okay. So, as you notice, actually, in the other books, there must be x1 minus x2 minus mu1 minus mu2. So, the mu1 and mu2 will be only used if it's given from the population. But since we are using the sample and we have no value for the population, we assume them equal, so automatic minus 0. So, that's why it's not reflected in the formula. All right, so we have now the t-test. So we will use now, go back to the table as to our reference. So we can use now. Remember that our variable here are the quiz scores. So the scores of the test, okay, scores of the quiz. Okay, that's the variable. So you can copy that, or you will just put that as 1 because all the data came from the scores. And then the mean of the first group, okay, scores of quiz, let's say of group A or section A or section 1. And then we can also have scores of the quiz of section 2. So what is the mean? So let's try to go here, go back. So the mean here for section 1 and section 2, mean 1 and mean 2. So these are the corresponding means. So we will just copy that. Okay, here. So the means and then base values. Okay, these are the corresponding means. And then we have to get the variances. So we have the variance. So you can also put equals the variance of the first group, which is var.1 here, enter. And then equals variance of the second group, which is var.2, enter. So this time, we have now the variances. Okay. So, we are going now to proceed to the t-test value. Sample size, rather. In the first group, there are 9, if you remember. And the second group, there are 13. A total of 22. Look at the total is 22. So, what is our t-test result? Our t-test result, based on our computation, is Okay, this is our t-test result. Enter. And then, what is our critical value? So remember, the critical value will follow with the degrees of freedom, n1 plus n2 minus 2 if equal variance, but this time we are using the unequal variance, so it is just simply n minus 1. Meaning, how many are n, no? So minus 1. So we will use the n of the smaller group. N of the smaller group. That's n minus 1 of the smaller group. So we will look at now in the table. So we will search. We will say T distribution table. T distribution table. Alpha level 0.05. For T distribution, we will not divide it by 2. So we'll visit in the internet. Okay, from statology.org. Okay, so we have here. We'll say two-tailed. So we'll go to 0.05. It's in here. And then our degrees of freedom is smaller n is 9 minus 1, so 8. We'll go to 8. So it's 2.306 under 0.05 two-tailed. So going to 8 is 2.306. So it's 2.306. So compare now. As you notice, our t-test result is greater than the critical value at alpha level 0.05. So therefore, our decision is significant, comma, and what will happen to our null hypothesis? Our null hypothesis will be rejected. So we have to reject. So meaning not equal. So not equal. So the other researchers are also interested to know, so who is higher, who is bigger if they are not equal. For sure, one is higher or one is bigger than the other. So if you go back to the mean, obviously the first group 36.11 has the bigger mean compared to the second group. So in here, section A, here, though they are only 9, has the biggest or bigger mean compared to the other group. So therefore, we can say that they are not the same. So significantly, A is greater than B, or group 1 is greater than group 2. Okay, so that is on how to use the t-test using unequal variance. Thank you very much.